Hello sir, we from Group 7 would like to explain our material on visual and audio media in thermodynamics. First, let's us introduce ourselves. My name is Ribka, Kezia, and my friends are Shefty, Yuliani, Siregar, and Yenji, Betaria, Sonata, Tampubolon. Our first topic will talk about system and environment in thermodynamics. First, we have to know the difference between system and environment. A system is a group of things that are important, whereas environment is everything outside the system. The state of a system can be known from the variable. Next, about the zero law of thermodynamics. The zero law of thermodynamics say that if A is in thermal equilibrium with C and B is in thermal equilibrium with C, then A is in thermal equilibrium with B. Next topic about the first law of thermodynamics. The first law of thermodynamics says if the system absorbs heat Q from its surroundings and does work W on its surroundings, the system undergoes a change in internal energy of U equals Q minus W. The heat formula can be expressed by Q equals N times C times delta T, and the work formula can be expressed by W equals PV dV equals area enclosed by the PV curve. Change in internal energy U equals N times C times delta T, with internal energy U is the kinetic and potential energy associated with microscopic quantities. Thermodynamic process 1. The first is an isobaric process. An isobaric process is a thermodynamic process in which a constant pressure. The isobaric process formula can be expressed by W equals P times delta V. Delta U equals N CV delta T. Q equals delta U plus W equals N CV delta T.
Thermodynamic process 2. So an isobaric process is a process at a constant volume. The formula of thermodynamic process 2 is W equal to 0, delta U equal to N times CV times delta T. So Q equal to delta U equal to N times CV times delta T. Thermodynamic process 3. An isothermic process is a process at a constant temperature. The formula of thermodynamic process 3 is delta U equal to 0, W equal to P times V times dV, Q equal to W, especially for ideal gas is PV equal to constant. The next is thermodynamic process 4. Adiabatic process is a process without heat exchange between the system and the environment. The formula of thermodynamic process 4 is Q equal to 0, W equal to PV times dV. So delta U equal to minus W. Especially for ideal gas is PVY equal to constant. Thermodynamic cycle. The first is the combination of various thermodynamic processes to form a process that closes. The formula is delta U equal to 0. W is the area enclosed by the P to V curve. Q equal to W. Number 2 is cycle efficiency. So the cycle efficiency is W per Q in, and Q in times Q out per Q in. One-way process. The first is gas in state B cannot return to the state A spontaneously, so this is irreversible process. Number 2 is the state of the gas can only be determined by the initial state A and the final state is F.
And now I will explain about the second law of thermodynamics. The learning objectives. First, students can understand about the Kelvin formulation. Second, student can understand the formulation of clauses. First, about Kelvin formulation. It said that there is no process whose end result is taking a certain amount of heat from a heat reservoir and converting all the heat into work. Second is Clausius formulation. There is no process whose end result is the removal of heat from a low temperature heat reservoir and the dissipation of the same amount of heat to a higher temperature reservoir. The efficiency is equal to absolute value of work per absolute value QH is equal to 1 minus absolute value of QC per absolute value of QH. Next, I will explain about the Carnot cycle. The learning objectives. First, through the pictures, student can explain how the Carnot cycle occurs. Second, student can also know about the Carnot cycle. The picture A represents the PV or pressure volume diagram of the Carnot cycle. The work done during a complete work cycle is the area closed by the curve of the PV diagram. There is also heat transfer during the cycle, and this transfer occurs in stage 1 and 3, since stage 2 and 4 are adiabatic, and therefore there is by definition the heat transfer during them. And then the picture B is the work cycle of the Carnot engine. It has 4 stages. Stage 1 is an isothermal expansion, and this expansion takes place with the cylinder in contact with the heat source of red color and temperature high TH. Stage 2 is an adiabatic stage in which the volume increases slowly while the temperature and pressure decrease. Stage 3 is correspondent to the isothermal compression of the gas at the low temperature Tc, and the stage 4 is in this stage the adiabatic compression of the gas occurs, which increases the temperature and pressure until they return to the initial condition in A. The next is about the Carnot engine efficiency. The learning objectives. First, student can understand how the efficiency of the Carnot engine. 2. Student can also find out about the equation in the Carnot engine. The great importance of the Carnot engine lies in the fact that the Carnot engine is the most efficient heat engine possible that operates between two given temperatures. Efficiency C is equal to absolute value of work per absolute value of QH is equal to QH minus QC per QH is equal to 1 minus QC per QH is equal to 1 minus TC per TH. And now is about the entropy. The learning objectives. First, student can understand about entropy. 2. Student can find out entropy equation. 3. Student can know the change in entropy. Every quasi-static process can be approximated by many small cyclical components which are Carnot cycle. From the Carnot cycle, sigma Ke per Te is equal to sigma Ke per Te plus sigma Ke per Te is equal to 0. Reasoning towards C, the Ke per T is equal to 0. For each quasi-static process applies C, the Ke per T is equal to 0. Entropy S is a state function like PVT. Change in entropy delta S is equal to SF minus SE is equal to integral F to E dK per T. The law of thermodynamics, delta S is greater than or equal to 0, reversible delta S is equal to 0, delta S irreversible delta S greater than 0. That is all about explanation. Sorry if there's a lot of mistakes of our explanation, and thank you.